As we live in this beautiful world, everything that seems around us is happening for some cause and reasons. The things that we can see, feel, touch, sense, all exciting a fascination towards our curiosity that changed the world and led us to abstract in the magical world of nature with mathematical expressions, derivations, and relative principles in terms of physical science. Well, one question will definitely hit upon your mind: how all the objects and bodies around in space and time stay together or attract towards each other. Let's take an important example: how all the planets revolve around the sun, how moons make the motion with respect to the earth, how we can able to stay on the earth, why object will fall towards downward the earth, why atmosphere is not in this space. We have an answer to all these questions that we have been discussing in this video. Well, they are like similar question asked which revolutionized our thought from an ancient period. Like in an ancient India, Aryabhatta was first to identify the force that objects are known thrown outward as the earth rotates. The ancient Greek philosopher Archimedes discovered the center of gravity. The Roman architect and engineer Vitruvius postulated that the gravity of an object did not depend on weight but its nature. Laterly, modern work on gravitational motion began with the work of Galileo Galilei in the late of 16th and 17th century. He showed that the gravitation acceleration is the same for all objects in his famous thought experiment, dropping ball from the Tower of Pisa. But the only one who came up on his idea of universal laws of gravitations are also called Newton's law of gravitation's motions, with the mathematical expressions, derivation and principles. In 1687, an English mathematician and physicist Sir Isaac Newton published Principia, that is reverse in square law of gravitations, and proved on the basis of Kepler's law of planetary motions, which we had been discussed later. Well, well, gravitations. In classical physics, Newton's gravitational law or universal law of gravitations, it is simply a virtually natural phenomenon of force of attraction towards each other between any object and bodies. So, to understand this, let us consider there are two bodies, A and B, that is placed at some distance r between them, and both bodies having some masses m1 and m2. So, according to the Newton's law of gravitational, both bodies m1 and m2 are tends to extract a force towards each other. So, the quantity of force is depend upon the mass of both the bodies, as it is directly proportional to the product of their masses. It means the larger the masses, the stronger the force of attraction between them. So, the force is also dependent on the distance, so as it is inversely proportional to the square of the distance between them of body A and B. It means the more the distance between the bodies or the bodies moves far away each other, the weaker the force it will become. So the equation is getting the F is equal to G m1 m2 by r square, where G is universal gravitational constant throughout the universe, which is same. So the characteristic of gravitational forces are: first, gravitational force does not need any contact between them. It can be act at a distance. Second, it is obey inverse square law. Third, it is form an action reaction pair. So now you get it, friends. What is gravitation? In part 2, we have discussed in more detail and gravity about. At the end of the video, thanks for watching. Don't forget to subscribe and share. And also don't forget to give a feedback in the comment section below. Stay tuned for upcoming videos. Thank you.